So welcome to our Wednesday class. Just wanted to kind of give you an update of where we're at. Um, we've done all of this stuff. We've done chapter 1. We did our holiday. Chapter 2. We did chapter 3, which puts us ready to take a look at chapter 4, which is going to be actually the content-wise, what we're doing is a look back to chapters 2 and 3. So we're doing the same type of equations. We're going to be using Desmos to do a lot of this. So it's somewhat review, but it's in a new sort of perspective, which is good. What we do today, we will then have Monday as an open lab day to come in and work through the homework questions and any questions you might have on using the technology. Any questions so far? Of course, very good. I've been watching the grade book, so when you get to your 10 points, which is about 70%, I've been, hello, marking you up to 15 out of the points. So get 10 points on the homework. On the quiz, they will become 15. So basically, we give you more questions than we need you to work, but if you work 70%, you'll get the full points. Okay, and you kind of see we're getting closer now. After we finish up this, we'll have chapter 5, chapter 6, some review, and then we'll have a midterm review exam over what we've been doing. Remember, for the midterm, you do get to bring a page of notes, front and back. Remember, I don't say the size of the page. You could bring a larger page, a legal size if you want, or a Dead Sea Scroll if you need. You'll have enough notes, okay? You can put examples on there. So it's what that is to kind of encourage you as you work through these to be writing down notes what you're doing, because that will help you for the exam. You'll put down examples of what you're going to do. Exam questions are going to be very similar to what we've been working on. Anything we let you use for doing the homework, whether it's an app on your phone or an app, a link, a Desmos online, you will also have access to that during the exam. So it's everything we're doing, okay? It's really just what we want you to do is we show you how to do things. We want you to practice a little bit and show us that you were here and did it and you're doing well. Okay, I'm recording this, so we'll post this afterwards. It's been doing this all morning. I don't know if it bothers anyone too much. I don't know. We'll record this so we'll see it, but it bothers me a lot because I keep seeing these flashes going on the side, and I go, okay. So we're in chapter 4, and this is actually a new slide deck I put together last night. So if you come into the lecture, there's a link to the presentation. I don't know that you need it open, but I'll be using it for the presentation. Once we have it, we'll record it here. One thing you may want to have is you may want to have Desmos open either on your phone. There is a phone app that does Desmos, or on your computer as we get to those stages, or you may want to follow along and do it later. There is a, let me back up. There is this regression with Desmos. So I'm going to be showing you how, this is another person who posted a video on it. Sometimes it's good to see two different ways. It might make more sense. So there is this here. There's a previous recording, but I think what we're doing in this lecture will be a little bit different, maybe a little more straightforward. But there's these two links here as well if you need those. Okay. But I think we've got it down to like 5 or 6 slides on here. So this is what we call modeling, mathematical modeling. What it is it's taking data. Maybe you're running a shop and you keep track of how much you're selling each day, how many t-shirts you sell. That's data, right? And we could take that data, and then what we're going to do is we do the math with it so that we can predict if we continue at this rate, how much will we sell next month? right? So we're projecting, should we keep the business open, or are we going downhill and maybe we should close our business? This is what what we're doing today will help us decide. If you're into sports, you practice, practice, practice. Are you getting better or are you getting worse? So those are the types of things we can record certain data, and then this is the realm of research. This is what researchers do. They take that data and then they try to project what's going to happen in the future. Or maybe we also can use this as a detective. We have two pieces of data, but we don't have anything in the middle. Sometimes we can take that data and predict what was happening in the middle. Okay, so that's what we're doing today. We're going to do something called linear regression. This is going to tie back to chapter 2 stuff. And we've actually already done some of this with 2 points. We're just doing it with multiple points. We're going to talk about correlation, and that's the relationship between the two variables. And that's part of this regression process. So these two are connected very easily. We're going to look at exponential regression, which is using data that ends up being a percent growth or percent decrease. So linear is an amount of change. So we did that last week. You're getting an amount of increase. You're getting $2,000 more each year on your salary. That's a linear change. If you're getting 2% change, 2% more each year, that's an exponential. So this is percentage change. So notice we've got amount change, we've got percent change, and then we're just going to look at some applications which ties them all together. And basically we've got tools that will help us see whether a process is linear or whether it's exponential, whether it is an amount of change, a constant amount of change, or whether it's a percent change. We'll be able to visually see that, and that's what we're doing today. So first we're going to start off with this thing called linear regression. What we're doing is we're going to take some data, and this is some age and value. We don't know exactly what this is, but some value as a person gets older, what's happening to this value? Is it going up or is it going down? Down. And so what we do is, it's really hard to get a math of all these data points are not following a specific pattern, but they're kind of linear, aren't they? We could put a line that sort of averages out those points, right? And that's what we call regression. The math of all these random, they seem almost random points, not really random, but figuring out these points, it's a fuzzy math. Let's put it that way. I think one of our presidents invented that word, fuzzy math. I think it was one of the Bushes, maybe. I don't know. Anyway, fuzzy math. When we get to the line, that gets very clear math. Because what does a line look like in mathematics? Yes, sir. It looks like that, right? Y equals mx plus b. Good. And in this case, we would see what kind of a slope do we have here? Is it positive or negative?
Going down, I'd say negative.
Very good. Very intuitive, right? So it's going to have a negative slope, and we're going to see. And the nice thing is we're going to have a tool that will do all the work for us. We just have to give it the points. Okay, but this is what we're doing. We're going to be given some data. We're going to plot them using Desmos, and then we're going to use Desmos to have it draw the line and give us the equation of the line, and that's what we put as our homework answers. It's going to also allow us to make predictions, so that kind of is what we get to a little bit later. Okay, any questions so far? Doing good? I think that's all I needed to talk about here. Well, no, we'll talk about that later. Okay. So here's an example type thing we're going to do with linear regression. Is we will be given data. We're given the year, and then we're given the number of Christmas trees that were sold in the US. So this is data. Is the number of sales going up or down? $27, yes, sir. primarily up. You might look, oh, this year it kind of went down. Okay, so and that's what happens with business, right? Nothing is always up and always down, but the trend we're going to see. It looks like it's the trend overall is going up. We're going to plot it and we're going to see it. Good, good. One things we do, remember these numbers for the years 2004, are we going to use that as our data? No, because it's really it doesn't help with the graph. What were we doing with when we had data that started in a particular year? We call the first year the beginning year, right? So we make that year 0. What does the next year become?
Year 1.
Be careful. Well, yeah, the next year, but how about the next piece of data? How many years of this is actually year 2. But you're right, the next year would be year 1, then this is year 2. Again, you could also see that if you took 2006 and you subtracted 2004, you get 2. So that's where that's coming from.
Oh, okay.
And then,
I misread that.
no, you were fine. You were fine. You were answering the question in general. And then 2008 becomes what year?
Year 4.
Very good. 2010 is year
6.
and then 2011,
7.
they threw the pattern off on us. So it's not always going up by 2, but
7-11.
7-11. Oh, yeah, there we go. So we're going to use this for our data for X. This is our X data, and this is going to be our Y data. Now, we're not going to enter it in millions because that would be way up there, right? So we'll just realize that when we have the number 27, that's 27 million Christmas trees, okay? I think we've already done this actually, but we'll go through the steps again. We're going to use Desmos to make a scatter plot. It's called a scatter plot. And then we're going to do the regression, okay? So we're going to go to desmos.com. If you want \calculator, and it will take you directly to the graphing calculator we're going to use. Let's go here. Keep that stuff. And so I go to desmos.com/calculator. And this is where we're at. Does anyone remember what is the first thing we do to put in our data? I hit on the plus table, right? So we're going to give them our X and our Y values. And so we come back here. The X's are 0, 2, 4, 6, 7. So I'm going to enter those first. It's nice if you've got 2 screens so you can have everything out there, but
Did not know about the plus thing.
yeah,
That was the only thing about Desmos we didn't.
okay, very good. So they're learning something new. Good, good, yes. And then we put in the Y values. And again, you'll figure what works best for you. If I had these up, I might put them, so 27.1. And remember, those are in millions. 28.6. And then I saw the next one was 28.2. And then it was 27. And then it was 30 point something, 30.8. Thank you. Now, we just created a scatter plot, but do you see a scatter plot? We don't.
Because we need to zoom out.
Very good. We're looking at our data. Oh, it's not fit. 0 to 8, our X is okay, but our Y's are not. We need to get out to about 30, right? So let me close this. That's where this little wrench comes in handy. It's graph settings. We want our Y's are only going to about 7. We want them to go up to 30. Actually, let's go to 50. The thing is, you want to go more than what your data is. So I'm just going to go to 50. As soon as I did that, look, I got a scatter plot. Okay, and you can say that. Would you say generally the values are increasing? Sure.
Yeah.
Yeah, from here it's going uphill. There's a little drop, but that, economy, that Christmas wasn't so well or something, or people bought artificial trees or whatever. But what we're going to do is we're going to fit a line to this data, a line that kind of will average it out. Can we draw a line that goes through each of these points?
No.
No, because in math, a line is a
Straight.
straight line. We do not have curved lines in math. Like you can curve a ruler, but you can't curve a line. Okay, so good. So how do we do this? We hit the plus key again, and we're going to put in an expression. This is where we put the line. So remember, equation of line is y equals mx plus b, but instead of the equals, we use a different symbol. So we are going to remember up in here, we're going to be putting y1, that reference, because the table has y1. Instead of equals, we're going to use this little tilde approximate thing. We're going to use mx, but not just x, x1, because this is x1 plus b. And that will tell Desmos find the line that fits this data. Okay, so now let's go ahead and type that in there. So I just, I'll do it with this keyboard. You can just do y equals, oops, not y, not equals, y1. And notice I do 1. Desmos automatically knows to put it down. And then I'm not going to do the equals. I need to get that tilde thing. And that is, if I go to the keyboard here, it's down here. If you're using a computer, that's generally next to the escape key. You'll see a little approximate symbol. So we put that in, mx. So I'm here. Let's go ahead and get m. And then I could use this x. I need the 1, so I go back to 1's. It's x1. And notice it's now starting a line, but I need one more part. I need the plus b. So I'll do plus, come over here and do b. And look at that line. Isn't that pretty? It's beautiful. Let's see how I turned it off. The nice thing is, well, maybe it's more pretty if you've made it orange or purple. You can do anything. You get creative with this stuff. Yes, excellent. And notice how we get all our math done this way. So we can see it's going through there. It's averaging out. It looks like a pretty good fit for those points. If you change one of the points, the line will change to adjust for it. And everything we need to know about this line is now, take this stuff out. No, it won't take it out. Actually, there we go. Is right here. They give us the slope. They give us the y-intercept. And so in the homework or in the quiz, we're going to see what are they going to ask us. They're going to ask us for the equation of the line. We will tell them, let me put it here. Our answer would be y equals 0. Let's do this to 2 decimal places. So to 8x plus 27.28. So that would be the equation of the line. Okay, that's one of the answers you might give it. Okay. All done for us. We just have to enter the data and do. Now, if you go to the textbook, that's part of this. There's a PDF file in there. The instructions it gives you is how to use a TI-84 calculator to do all of this. It's a little bit more steps because you're having to do things. And the ones I can't really, but I've had students that would prefer to do it with their TI-84. They've used it before and they're familiar with it, or they want to learn because that's what they're going to have. You're welcome to do that. But Desmos is free. It's online. You'll have access to it. And it's fairly visual. So that's why I use it as my tool. And it's free. I know that all of you have access to it. You might not all have access to a TI-84 calculator. But if you want to, their instructions are in there, and I'd be happy to help you learn how to use that as a tool. Okay, questions? That's the first section, linear regression. You're just going to put in data, make sure you zoom out or zoom in, however you need to do for your data, and then get it to draw the line. Remember, I'm saved. I could save this. Actually, I'm already logged in from last time. So I could save this. Ask me for a name. How about I call this Christmas, or I'll do Xmas trees. And if I click on this, watch what happens. It's right there. When I go out and I come back, I could pull it up again. If I had a test that had a similar type question, I don't have to recreate all this. I maybe just have to change my numbers. Yes, sir.
Why not make it a little math joke and say y equals x and xmas plus b?
Oh, you caught that. Xmas
Figure it
plus
would be
b.
funny.
Sure, we could do that. We could do that.
That can be a title.
Yeah, easy way to remember it. Okay. What I wanted, actually, we're going to do the next section while we're right here. So tell me, is this line going up or down?
Up.
It's going up. And so the slope is positive, right? It's got a positive slope. I want you to pay attention. How close are these points to this line? You say it's a good fit, a great fit, and a perfect fit? Well, first, is this a perfect fit? No.
Not necessarily, because they're not on the line.
They're not on the line, so it's not perfect. And the way we can tell is this value over here. This is the R value is telling us if it was a perfect fit, R would have been equal to 1. That means every point was right on that line. Okay. This is what's called correlation. I've got some more slides that will spell this out. Correlation. And it's giving it to us here. So I want you to see is while you're doing regression, you're getting the correlation number as well. So 0.5 is not perfect completely. If it was not like a line at all, then R would have been 0. And had it been decreasing but perfect, what would R have been? Any guesses?
-1.
You got it.
Because negative, of course, means descending.
You read the book already? Good. It's exactly right. So if it was going downhill and perfect, it's -1. If it's going uphill and perfect, it's +1. And if it's scattered like this, it's somewhere in between. Okay. And so the closer they are to it, so what we would say is, and again, it's all such a judgment thing. If we're about 0.7 is usually good correlation. That means as time goes on, it's good predicting that this line would be a good predictor. This one is just sort of an okay predictor. It's not great, but it's not too bad. Okay, about 50% of the time. Okay, so now that we've gotten that part, we're going to go back to the presentation. Let's see, back to this. So that's regression. That's 4.1. So we'll have some problems on that. That's all you got to do is put it in there. Correlation, what is it? We just talked about it. It is how close those dots are to the line. And we saw this one.
Strong is close together, but not exactly in line. Weak, not close together, and not in line.
Very good.
If it's weak, then the cluster is not consistently strong.
Very good. So it's kind of a weak, it's positive, but it's weak. It could be something like the temperature versus buying ice cream. When it gets hotter, are you more likely to buy ice cream? probably. But some of us like ice cream in the middle of winter too, right? I do. Give me a milkshake or something. I love milkshakes, but so we might, but when it gets really hot out, maybe, ice cream sales will go up, but it might not be a perfect relationship. Okay, stuff like that. So that's what correlation is about. It may not be that the hot weather is causing people to buy ice cream, but it might be that they do it more often when it is hot. Also, I'm lactose intolerant, so I can't have too much of it myself. So I don't know about y'all, but uh, I love it, but it doesn't love me. So that's our correlation. But if it was going downwards, we also have the same things, right? We've got a perfect but negative. So they're all right on that line. Strong but negative, they're going downhill. And weak but negative. And again, that might be something. How many golfers do we have here? Golfers. So if you practice a lot, what do you hope your golf score will do? It will go lower. So the more you practice, the lower your score. You want a negative correlation between how much you practice and how much you score. So there's sometimes we want things to go down when we do something more often. We institute some crime reduction program. We're hoping crime will go down as we increase something. Increase the kindness, maybe the crime will go down. Whatever. But there's one more thing. There's no correlation. This this is going up, but this is going up and down. There's really no correlation. Yeah, I don't know what the sales of, it's all over the place. So yeah, one thing's not really related to the other. And so we talked about this already. We get this sort of scale. We get weak correlation at 0. As we get towards either +1 or -1, we get a either strong negative or strong positive. But the strength increases in both directions. Okay, and that's, again, there's a way of calculating that. Desmos does it for us. It's a very complicated formula, which I, as a math major, I had to use when I was learning all this stuff. And we're not going to make you use it. We're going to let you rely on Desmos, or the TI calculator does it. We're going to let that just be calculated for you. But just notice when you get that number, it's going to tell you basically how strong or weak, or whether it's sort of strong, negative, perfect, weak, whether it's a weak or whether there's no correlation. As we get closer to 0, we say there's no correlation. Are we okay with that? And again, some of the questions, I'll give you some of these dot pictures and you'll say rank them, which one has stronger, which one's weaker, and so forth. Okay, and it's just kind of it's a judgment call. We're not going to have you actually calculate it. Okay, we're halfway done. Actually, we're more than halfway done, because we only now need to do exponential regression. So what does an exponential, does this look like a line could fit this really nicely?
Well, not exactly.
Yeah, I mean, we could, but that's not a very good fit. But what does an exponential function look like? An exponential function has a curve to it. And we haven't talked a lot about it, but that's when we have, so the green line is y equals mx plus b. The red curve is an exponential, which is y equals ab raised to the x. And b is a percentage change, so it's increasing. We'll see how this works. But that's what I want to do is we're just going to jump out here. We did, in the homework, we did talk about this equation. Remember, the a is the starting value. I don't know, they had like home prices or something. So there was some problems that you would have done. Maybe you started with a salary of $23,000, and then you got a 5% raise each year. That would be 1.05 because that's a markup. So that's a 5% raise, and we raise it to the x power. That's an exponential. And we're going to see that will fit the data. The only thing that's going to be different from this and linear is that we're going to put, instead of the linear equation, we have Desmos do exponential. So the equation we put in will be different. Okay, we're doing this. And again, what we will put in is y1 is approximately ab raised to the x1 power. So that's the only difference between the two types of regression. We will also get an R value, and sometimes we're going to see in the next section, we may do both of them to see which one's the best fit. Okay, so we're going to go to the next set of data, and we're given this data and we're told, when do we do exponential regression? Well, when they tell us. They're telling us don't do linear, do exponential. And so we're going to plot this, and we're going to see it probably has a bit of a curve to it rather than being a straight line. That's why we would do it. The other thing we'll see is whenever we have population, again, either growth or decay, this is actually going down. Some maybe not very good management in the town, people are leaving. Used to have 125,000 people. Now we've only got 5,000 people. Everyone's running out of town. So, but this, it's happening. Usually population growth or decay is by 1%. So we're going to see that, all we have to do is we're going to go to Desmos. We're going to put our data in, and I think I can actually do both here. So we're going to keep that. I'm going to go back to Desmos. I'm going to take it out of here. I'm going to shrink it down a little bit. I think I can do this. I'm going to get rid of all this writing. And yeah, I think I can kind of do this. I'm going to, what I'm going to do is I'm going to leave this here because I'm going to use it as a comparison. I'm going to just turn it off by clicking on that. So it's actually not going to show it over here. It'll still do its stuff. The data, I'm okay with this. I just need to change it, right? I think I got 0, 1, 2. I think I can, let's see if I can highlight all this. I don't know how to clear it off real nicely, so I'm just going to clear out the data. If you wanted to, you could start with a new table. You start with a blank sheet, but I'm just going to show you, you can also sort of clear things out. Just deleting the data. And then I'm going to put in this new data. So 0, 125, 1 and 75, 2 and 50. And incidentally, I took these this chart from the book. So then we've got, okay, let's do 4, 6, 9, 12, 16. 4, 6, 9, 12, 16. Let's see what I got. 32, 22, 16. 32, 22, 16. 10 and 5.7. Thank you. 10. Yeah, I need help on these. So thanks. So I've got all my points here. And notice that was really the same thing as if I was doing linear, or linear regression. And I come back here. Let's get this out of the way. See, my data goes from 0 to 16 in the x direction. So I'm going to go from -10 to, let's go to 20. I should see all the data that way. The data goes to 125, so, and then it goes down from there. So my y maximum, let's make it 150. So now I can see all my points. It doesn't really look like a line, does it? It looks more like a curve, right? This looks like it should be exponential, which they told us it should be. So what we're going to do here is we're going to do one more plus. I'm going to add an expression, and this time I'm going to add an exponential expression. So that's y1. Do this y1, so it gives me that. Again, instead of the equals, we put the tilde, and then we do a, b, and we have to make an exponent. This is the little button here for the exponent, a to the b. And watch when I click on that, it gives me this, it moves up there, and that's where I put my x variable. So I'm going to put x1. And notice as soon as I do that, it goes ahead and draws the curve for that. But be careful here. There's one more thing I need to do. You need to click this box called log mode. Why? Because you do. I don't know why, but it won't give you the right, you won't get the right answers. But as soon as you click that box, you will now match the answers in the homework. So log mode is what typically uses. If you're using a TI calculator, it's the default is log mode. But for some reason, and again, I didn't ask the question. I just know when I click the box, I get the right answers. If I don't click the box, I get everything wrong. They're similar. And notice it does adjust it a little bit. If I click it, it looks a little different. So log mode seems to fit it better. Okay. And then what we have here, and we're almost done because then the last part is just putting this together. It's nothing new. Notice, why is my R value negative? Exactly. Good. Good. And is this a good fit? What's that value?
Except for that top one up there.
It's not perfect. If it was perfect, it would be negative 1.
Yeah,
But it's negative 0.97. It's close, but it's not perfect. Good. Yes, there's some parts that could use some help. So excellent. It's a very good fit. And my equation I use is this is my model up here. If it asks for the equation of this, what I would put in is y equals the a value is 82.94 times the b value is here, 0.84. Yeah, good. We round it up to the x or to the t or whatever they wanted. That's my equation. If you remember back from Unit 3, Chapter 3, we can see this is decreasing. How much? What's the percent of decrease? Close. We're using 84% from the inside there, but that's not the amount of decrease. What do we get? We're decreasing from what?
we're decreasing from 84. It's actually decreasing by, decreasing from 100.
That we're decreasing from 100. We're getting 84% back is the way to think of this.
So
you got it. We got to. So that's this tricky one. No, it's we do it all the time. We all fall into that. So it's a 16% decrease. Okay, so that's the kind of thing we're looking at.
That's what I was gonna say. We were decreasing it.
Very good, very good. So you'll develop this intuitive. It's oftentimes easier to see above because if it was a 16% increase, what number would we have? 1.16. You can kind of see that's 100% plus 16%. The increases are typically easier to see. I mean, they're right there. 16%. These ones we have to do the math. We have to subtract it, and sometimes we forget. So just remember that that's what that is, 16%. We've got our correlation. It's got a good correlation. What I'm going to do with this, I'm going to take this off, and this will get us into the last section, which is modeling, because sometimes they'll ask us which is the better fitting model. They might have us do both exponential and linear, and that's why I didn't delete the other one. Let me get this out of here. I'm going to just turn this on and watch what, wait, I have to get there. I'm going to turn this line on, and it's going to fit a line to this data. What do you think the R value is going to be? Is the R value still going to be close? Well, first of all, is the R value going to be positive or negative? It's still going down, so it'll be negative. But it should probably, because if it's not as good of a fit, it should be less than 0.97, right? Hopefully it is. You never know on these things. You just try. And it is, isn't it? The R value is 0.81, negative 0.81, which is not as good a fit as the exponential. So this is one way we can measure which is the better fitting model. The exponential model fits it better than the linear. So that's the last section, is they will give you data and they will ask you which one is the better model to use for this. You just graph them both. So a lot of times I would just save this. If I need to do exponential, I just say, okay, turn this one off for now. If I need to do linear, turn it on and turn this one off. And if I need to compare, I turn them both on and I can compare. Okay, you say, oh yeah, the red is a much better fitting. This line has some problems here. It's further away from these guys. It's close to those. Linear is not a very good fit, but you'll be able to do them both. And that's the last section. So the key part, that's why I like Desmos. It's so easy to do both of them on the same thing. The TI-84 is more difficult to do it all on one. And it's just more difficult by itself even. But Desmos, once you get used to it, I think you'll really like it. It's also got an app where you can have it on a smartphone or a tablet. And so it works that way too. So you could still be doing your homework on your computer, use your phone to do a Desmos. But that's what we're doing. Okay, so 4 is just this, put chapter 2 and 3 together. You're doing research, you're able to predict future values. Let me do this one thing. This was, what was this data? This was population. So 16 years. They're missing a year in here, right? They go from 6 to 9. What if we were interested in, say, what happened in year 8? How could we figure that out from, oh, we need to go back to Desmos. So if we wanted to find out what happened in year 8, let me zoom out a little bit. I'll show you what you can do, is we can add one thing. We can say what happens when x equals 8. Notice we get a vertical line and we get an intersection point. Oh, population was about 20, 19.9. From this line, even though we don't have a data point, we can make a prediction here. If you wanted to predict when will the population be a certain value, the values, is that an X or a Y value? It's a Y value. So if I wanted to predict when the population would be 30, I just put in the line Y equals 30. And notice I get an intersection here. That's about the year 6. It was about year 30, right? 5.7. So you can then use your line or your curve to answer some math questions. And with Desmos, you don't actually have to plug it into a formula and do solving. You just put in either the horizontal line for a Y, a vertical line for an X, and find where they intersect, and you got your answer. Okay. Sound good? Let's see. Ready for some quiz questions? See if it's yeah, I think this is enough. I'm never really sure because I don't remember everything that's in there, but let's go for our quiz. We're still recording, good. You'll see we're just going to be going back to Desmos for the most part. Yep, we got data, and all we got to do is get into so let's see, maybe make it a little bit bigger. Use linear regression to find the equation for the linear function. So we just have to put this data into Desmos. There's my Desmos. Again, I'm going to clear out these last ones that I did. I'm going to leave, they want linear equations, so I'm going to put the orange line, I'm going to take the red line off. The reason I don't delete this is if I delete this and ask for another table, you know what it's going to give me? It's going to give me x2, y2, and then I have to go up and change my equations. And I'm lazy enough that that's harder for me to do than just to delete all these guys. And if you find a method that works, I was trying to see if I could highlight it and delete it all. I haven't been able to do that, but this is kind of pretty quick. And now I just need to put this data in. Let me see if, I'm going to see if this works. Sometimes it does. I'm going to highlight this data. So this is my X data. I'm going to do control or command or control C to copy it. And I'm going to come here in X. I'm going to see if I can paste this in. No, it pastes it the wrong direction. But sometimes you can play with that. Sometimes you're going to be able to copy and paste. And if you can, it's a lot easier. And then you don't make any mistakes. But we can also do this, right? To 6. And then now, these are the numbers I wish I could copy over, but 658, 43, 64, 12,914, 50,778. Okay, thank you. See, that's my problem. Okay, I skipped one. 28,922. My dad was a data analyst, and he'd always say garbage in, garbage out. And that's, so yeah, you put the garbage in, you get garbage out. Okay. 50,778. And then 86,431. 86,431. Okay. So we've got all that data in there. We don't see much. Again, we're going to have to zoom out so we can do this. Now, if you don't want to look at it, you don't have to. You'll actually got the equation up here that you need for your answer. It will calculate it. But I always like to see what I did. So what's our biggest data point? 86,000. Let's go to 100,000, right? So our Y, and that's a Y value. Make that 100,000. There's 100,000. There's all my points. Okay, now it seems right. But again, for this question, I got 16.68. That's my slope. I got my initial value, my y-intercept of negative 27,733.7. So let me see if I move those over there. They give me the y equals, and they want it to 2 decimal places. This is where we sometimes have problems because the decimals doesn't give me 2 decimal places, right? 16,689. X minus 27,733.7. And it matched. Okay, so we might not do all of these, but that's what you're going to be doing. It's just using decimals. Get the data in there. Everything, as long as you don't make the kind of mistakes I was making, as long as you get it in there right, it's going to be right. If it's wrong, check your data. It's probably transposed the number. You probably put a number in the wrong place. That's probably what happened. Or if it's exponential, you might have forgot to check the log mode. That's what I do all the time. Even after I've done it this time, I forget to check the log mode. I get it wrong and say, oh, I should check the log mode. That's why you get multiple tries. Okay. Here's another one. Oops, let's, so they give us data and then we need to get the equation. Okay. Let's see. Linear regression, same thing, right? I don't want to kind of bore you with the same details. It's just putting it in, doing the regression, and then you get your slope and your y-intercept. Notice they don't ask for the equation. They're just asking for the starting value, the y-intercept. What was the value? That's going to be your b value. And then down here, they ask for the rate is dollars per year. That's your slope. So you're going to put the value for the m in here. Okay, is that kind of clear? Okay, and again, you may have different numbers and such. So I'll just kind of help you work through these, but it's the same process. Get the data into Desmos. Desmos will give you your line. Okay. Here's one we can kind of do together. Here's a regression on R value. Which R value implies the stronger linear relationship? Which one of these is the strongest? Is 0? No, that's a very weak one. Yes, sir. Negative 0.6 is the closest one to either -1 or +1. That's good. 0.4 is positive, but it's further away from +1. So this question was just whether the strength of the relationship. How close are the dots to the line, regardless of whether it's going up or down. So it's whichever one is the closest to 1 or -1. So negative 0.6 was correct because it's closest to it's closer to -1 than 0.4. It's closer than -0.5. So that's going to be the strongest relationship.
Does it have to be like closest to like positive or negative?
Right. So if we had a 0.9 in this one, we would have chosen that one because it's closer to +1. But whichever one's closest to the 1. Yeah. Or negative 0.97. That's a very strong. So as we get to those, either side, those are stronger relationships. Right.
They have the biggest, they often the most, it's like not the biggest number, but the one with like the biggest
Right.
impact.
Right. Yes. Yes. There we go. There we go. Exponential regression. Again, I'm not, unless you really want me to go through this, it's put these into Desmos. You'll get a scatter plot, do it. You'll get an equation. We could do this one because then this one asks us to look up a few values. You want to take a look at this one? I got nowhere to go, so I don't mind. Let's go ahead and put this one in, and we'll do a regression. There's 4. This is one with modeling, so you have to actually determine whether a linear or an exponential is best fit, and that's it. So we've done both of these. So again, I'm going to come here. I'm going to turn off the linear. We're going to turn on the exponential. And again, we put in new data. So we've got 0, 3, 7, 12, 14, and 19. I don't know if we can, let's see if I can delete these boxes. Yeah, if I just hit backspace. 3,900, 4,552.06. Sometimes students will ask me, do I really have to put all of these points in? What do you think? If I didn't put in a point, would I be accurate?
No.
No. So even every point is important. And getting them in the right place is important. So watch me, because you know me, I might stray off somewhere. And that's the thing you'll find is, and if you get 1 point wrong, you can't get the right answers. Your answers won't match. 14, 88, 17.53. And then finally 19, what's that point? That's 11,209.85. 11,209.85. So we got all the points in there. We've got our equation. We've got our log mode check. This is the reason I also like to have it saved, because I don't forget to do that. And so let's take a look. We could change. We don't have to go quite as high as we've gone. You know, maybe 20,000 would be enough. Or yeah, don't have to go to 100,000. Maybe 20,000. A little bit more compact. But the first question is, what is the equation of the line? We've got our model. It's a b to the x, so it's going to be 39 or 3,914.3. B is going to be 1.058. See if I can get that in here. Three nine one four three 3914.3. Yeah, that's that. And then I would do parentheses 1.058. See, they want 8 at 2 decimal places. They only gave us 1, so I'll do 30. And the value b to 3 decimal places. So that's 0.058, but there's a 7 here, so I'll round it up to a 9. Very good. And then I need the exponent, so I come here and I put the little x exponent, and up there I'll put, be careful, the variable they're using is n instead of x, so I put a little n up there for number of years. So this should be about right, and it's exactly right. So notice, if you put it in right, you have your log mode checked, it will give you the right answers. Will give you the right answers. So based on the regression model, what is the percent increase per year? Where does the percent increase come from? Yes, sir. Oh, just stretching. Okay. What does this number here tell us?
It's
We can think of it in terms of a percent. Does that mean it's increasing by 105.9%?
Actually, it's increasing by 5.9.
Very good. Remember, the 100% is what we started with, so we're getting additional back. So this is really 5.9. And if you click here, 5.9, you get that. Use your regression model to find P when n equals 13. Okay, so this was what I was showing you as well. We can come back here and make this bigger. So remember to do this, we just add another expression. We let in this case, we're using x equal 13. That gives us a vertical line. And then we just click on the intersection point. There's our answer, 8,223.78. So we get it exactly. Did all the math for us, right? It's all visual. Again, a TI calculator could do all of this too. It's just a little bit more complicated to put in. This is the easiest I have found, and it's nice and I mean, it's whatever size screen you have on your computer. If you got a big screen at home, you could put it on the big screen and see it all. Okay, but does that make sense? And we'll just check here. Yeah, 8,200. Oh, wait a minute. Oh. I'm glad we did this one. We didn't match, right? I would have put 8,223.77. They say it's a different number. Why? They are using this equation. What is Desmos using? Desmos is using the regression equation, which is more accurate, but it's got more decimal places. So I forgot about this. When you go to answer these extra questions, what you need to do is you need to stop this equation. In fact, I'll turn it off. And what you need to do is you need to put in the equation y equals, you need to put the rounded equation in, which was 39 14.3, and I'm getting that from down here, but I don't put in, I need to put in 1.059. I need to use the rounded equation and then raise to the, I need to put the exponent there to the x. Notice it looks very similar, but now when I click on it, I'm matching the homework's answers. Yeah, when I come back here, 8,247.11. It's a rounded. It's exactly, so I'm going to match those answers. So just remember the Moore system uses your rounded answer, so you need to have Desmos use your rounded equation too. Otherwise, your answers aren't going to match. Typically, you would actually be more accurate to leave it in there, but just know that. So if you're doing research, I would leave your original equation, but because we want to get homework points, we would change it. Does that make sense? Okay. The population of the town after blank years is blank thousand. Let's see. Interpret your answer by, let's see. Okay. Oh. So this is, we've already got our answers. So what it's saying is, what is the 13? 13 is the number of years. So we have to come and take our answer from up here. 8247.11. What that answer means is after 13 years, right, the population is 8,247.11. Okay, so they just have you use it. And this one I'm just going to let you do on your own. Again, you're going to do this one both as a linear and as an exponential. You're going to write those two equations, and then you're going to use the R value. The one that's closest to 1 is going to be the better fit, or closer to -1, depending upon whether they're going up or down. This one's going up, right? The numbers are getting bigger, so this would be whichever one's closest to +1, and that's what you'll choose. Notice that's all this is about, using Desmos again and again and again. And you're good. Okay? Questions?
I can just go back up.
This one here?
Yeah.
Good. So we have actually a full, more than an hour and 5 minutes if you want, to go back and start working on the quiz, on the homework, whichever you'd like, or take a break and go get some lunch, whatever you need. Monday is a full work day, so we'll be able to help you work through these. And again, if you still have stuff to do in chapters 2 or 3, that's okay. That's kind of what we're doing now. So this is a good time to go back and review, to bring it all together, do your best to kind of maybe finish this up. When we go in after next Wednesday in a week, we will get into chapters 5 and 6 is financial math. So it's kind of like different. So 2, 3, and 4 are kind of connected, and then 5 and 6 will be connected with how to calculate savings and loans. So doing financial math, you will have. Well, we'll introduce you to a couple new applications that you can download to your phone that will do these calculations for you, and hopefully you'll have fun with it. I used to be in financial planning for 13 years, so I'll share with you what I know about that field, and that's kind of what will make this, that's you'll learn how to plan out your future for your retirement, plan out your use of loans for buying things, and you'll be set to chart your course for success in life. That's all I got for today. So we'll pause, or we'll stop.